Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. My name is Mohamad Ridzuan. Together with Mohamad Asyraf, we'll do a video presentation of our mini project for refrigeration and air conditioning course on designing and justifying an air conditioning system based on its required application and uses. Okay, now let's proceed to the methodology we use for this project. To calculate the cooling load of buildings, we apply the widely used and straightforward cooling load temperature difference, or we call it CLTD method. This method will utilize the temperature difference between indoor and outdoor conditions to estimate the cooling load. By using the CLTD method, we divided the building into different parts, including walls, windows, and also the equipments. Each of these components will assign a cooling load temperature difference (LTD) value, which represents the temperature variation within the component that contributing to the cooling load. Okay, as shown here in the slide, there are several steps involved in calculating the cooling load of the building. First, we need to choose the suitable floor plan, and then we collect the required building information. Next, we calculate the load of the wall conduction, and then we also calculate the load of glass conduction and also radiation. After that, we calculate the internal load, which is occupants and also the equipments, electrical equipments, and then we find the total of the cooling load value. Lastly, we choose a suitable air conditioning system depending on its CFM value. Okay, next, allow me to present the specification of the building we use for this project. The first, we have the floor with the size of 27 feet to 17 feet, and the wall with the height of 10 feet with 6 inches of thickness. And then we have windows of double glaze clear. And then the purpose of this building is for residential. And then lastly, the timing is at 3 p.m. where the maximum temperature occur. Okay, now let's take a look at the occupants and equipment within the room. Okay, the room accommodates 4 students engaged in light work. Each student produce a sensible heat of 1000 BTUH and also latent heat of 800 BTUH. There are 500-watt fluorescent lights present in the room, and two 10-watt wall plugs are in use. And lastly, 4 mid-range laptops with a power consumption of 55 watts each are utilized.
So we continue to the calculation part, the important part. So basically the load involved in the internal load, wall conduction, glass conduction, and glass radiation. So this is the list of the wall conduction. We just use the west zone, the maximum degree temperature type of temperature. We get it from Asyraf climatic design condition, and the values, all the constant value that we use in the calculation. We use using the Asyraf 1997 fundamentals as our references. So this is the internal load that uh, we use to calculate the load from Q1. So this is basically the calculation. So the Q1, the total of Q1, we get it 4323.4 BTU per hour. So this is the wall conduction load. The formula is Q equal to U area of wall times the CLTD corrected. So CLTD corrected is CLTD corrected by the conduction correction. So we get the value of CLTD from the table 32 Asyraf 1997 fundamentals. So after we calculate the wall conduction load, we get the Q2 is equal to 3051.4 BTU per hour. So next we continue to the glass conduction. Basically the formula is U equal to area of glass times the CLTD corrected. So basically the CLTD for glass, so we get it from table 34. So the Q3 we get it 11.664 BTU per hour. So next one is the glass radiation. The formula is Q equal to area of glass times SC times SCL. So we get the value of SC and SCL from the table 11 and table 36 respectively. So the answer for the Q for the glass radiation is 2566.088. So the total cooling load, we just add the summation of the Q1 plus Q2 plus Q3 plus Q4 is equal to 9952.54 BTU per hour. So we convert it into the CFM unit, cubic feet over minute. So we get the 469.45 CFM. So the suitable air conditioning system for this type of CFM 469.45 is Daikin. We get the three types of Daikin: FHC 85A V1M, FCC 50A V1MF, and also FCC 60A V1MF. So in conclusion, that the time we as cooling load graph that shows that 3 p.m. correspond the time of the peak cooling demand. So the cooling load at 3 p.m. is 469.45 cm, which is represent the highest volume of the air needed to cool and maintain the suitable indoor temperature during this peak period. So this information and this calculation is important to get the suitable of the air conditioning system to make sure that the cooling load is achieved and also the environment is also suitable. So maybe that's all for us. I hope you enjoyed this video. Thank you. Have a good day.